Okay, welcome everyone. We're just about to get started here. There's a little bit of a YouTube delay, so we'll see it when it shows up. But I wanted to welcome everyone who's online and tuned in to this year's Google Summer of Code project showcase. So all summer long, we've had an amazing group of students who have been working with us here at the Cdli, the Cuneiform Digital Library Initiative, to undertake certain programming tasks and development kind of features of the project and help make it a better project for researchers, for the general public, for the sort of wider scholarly and public community in general. So we're going to be we have about a 2 hour schedule where we're going to be going through the different students. They're going to be giving either live presentations or pre-recorded presentations. And there will be periods of time for questions at the end. I'll put up a schedule. You'll see a schedule. Hopefully you saw a schedule in an email invite you got as well. Um, and and like I said, we'll go through. We have about 5 talks at the beginning, then a period of questions, then 2 more talks, then questions, and then 3, and then questions at the end. Because of the YouTube delay, I really encourage you, if you have a question, pop it into the YouTube chat right away. Don't wait till the end of someone's talk. Just put the question in the YouTube chat, and then when we come to an actual question period, we'll then just go through and start reading them in order. So don't wait for a question. Feel free to just type it and ask it. Before we get started, though, we want to just give a brief message. So unfortunately, one of the real leaders in the field passed away this summer. So we want to take a moment to remember Bob Englund, who was the founder and director of the Cdli, who passed away in May. He was originally from Washington State, studied at Berkeley, in Chicago, and Munich, all great Assyriology institutions, and worked in Berlin before arriving in Los Angeles to take up the chair of Assyriology in 1996 at UCLA. Bob was the world's leading expert of the earliest texts from Mesopotamia, and probably from anywhere in the world. The so-called Proto-Cuneiform texts of the late Uruk period. Dating to the second half of the 4th millennium BC, Bob was also the leading specialist of the 3rd dynasty of Ur and the Ur III period. It was his knowledge of these 2 periods and their vast and complex administrative sources that led him to create the Cuneiform Digital Library Initiative, initially as a powerful tool to study the texts from early Mesopotamian history, and then driven by a never-ceasing sort of wish to make the textual record of ancient Mesopotamia freely accessible to everyone, the Cdli quickly expanded to cover all periods of Mesopotamian history, and ever since really has become the leading project in Assyriology, and one of the most successful and largest projects in digital humanities, a very early digital humanities project. Bob was also a really dedicated mentor, a good friend, who'd always speak his mind and always supported his students and friends, so he's much missed, and we want to kind of dedicate the work that was done this summer in his memory. Okay, with that said, now let's hop into let me just pop up the schedule briefly. So we're going to start with Aman Singh, who's going to be talking to us about his work on digital asset management. So Aman, if you would take over, can you share your screen?
Is it visible now?
Yes, it is.
Thanks, Philip. So my project is digital asset management, and more particularly about converting raw images to archives. I was mentored by Dr. Jacob L. Dahl throughout this. So let's dive into this. I'll just present it. Sure. Is it still visible?
I don't see your screen yet. I just see your audio.
Is it visible now?
Not yet.
Well, I'll try to share it again. It's visible. I think it's visible.
So I'll go through maybe it. I'm not. Maybe I've.
Let me. So the problem statement was.
There we go. I see it.
Yeah. So there was a lot of raw images inside the framework, and they were processed manually or using some scripts to ease the task, but mostly manually. So the first problem was to eradicate this. Then the second problem task was to append this kind of system to the current framework. The third and fourth tasks are actually merged. So basically, they define how we can effectively crop these images in a set amount of time. And how we're going to create an algorithm that can take multiple maps or different type of maps, like for example for tablets, for cones, for any other kind of shapes, and make them a particular one object. So the solution to this was the algorithms formulated using morphology, which is a stream of image processing that uses maths. So we are not using a lot of computation, and to put figures into picture, we can almost process around 200 small size flatbed scans in almost 8 seconds. And after that, we have an object-oriented approach to do the whole thing. That basically helps us to extend this project to multiple objects. And then we need to have a method to connect different runtimes, because the whole thing is done in Python and the framework runs on PHP. So I'll just go ahead and give you a quick demo, and then we'll see the rest of the things. So this is the current framework running on off my machine. So the first thing we have to do is this tool is meant for admins. So I'm gonna log in as an admin. So here we need to enter a 2FA code, but right now I'm in a development environment, so I can skip it. After this, I'm gonna hop into admin dashboard and look for the archival tool, onto which I'll be presented with the screen to have to add these images. So I'm gonna quickly add these images and show you how this works. So let's say 45. Let's go with the 45's P number set of images. And as we can see, it gets rendered in a green box, which basically means all the 6 sites are present. And I'll show you what happens if that's not the case. So I'm not okay. So I'm leaving out RENTE images. We'll see that on the pane too. Yeah, so they get rendered in a yellow color box. That basically means all the sites are not present. And let's try some random image. Let's see what that ends up with. So the file which are not formatted in a particular name get rendered as an incorrect box. These would be still uploaded and would be further extended to work, but right now they don't work, so it's not advised to upload them. So we can just get rid of it with a cross symbol, and we can move ahead with upload. This is gonna send all these files to our file servers, and very soon we'll see an empty pane. That means everything is uploaded. Now we're gonna go to the dashboard, and on the dashboard we'll see 10 files were uploaded. Now these 10 files were constitutes for 6 files for the 45p number archival, and 4 files for the 55p number archival. Now the thing here is that we create tasks for every archival. So when we see a green box being rendered, that means all the 6 sites are present, and we might successfully create an archival with this set of images. And a red box basically says that the amount of images present in there are less or more. So we need to be careful with that. So I'll fix that. So right now I'm unselecting it, so we can actually select which archival we need to process at the moment. So I'm going to go with 45. I don't have 45. It's fine. So I'll just create a task. 45 is going to pop up into the processed archivals task. And now we have the edit page. There is a bit of a problem here, but it's functional. So what this let us do is, while cropping the images, we do lead to losing the orientation of it. So this lets us rotate images and correct their orientation, and actually have a brief idea how the archive is going to look like. This still needs some work, but yeah. So let's say this is what I want my final archival to look like, and then I'm going to click on generate archival, which is going to create another box, the final box, for the 55th element. Yeah, this is not, we did 50, just a second, we did 30, right? 30. Yeah, I missed what exactly we did, but it's going to pop up as in final archival, something like this. And about something we missed. So we had 55p number, which was having 4 images. We had 2 more images, but we couldn't process it. So let's now try to process it. I'm going to go to the archival tool. And I'm going to choose those 55's LE and TE edges. Sorry, RE and TE edges. And I'm going to make an upload. Now, as we know, we have already uploaded 4 files. Now we have uploaded 2 more files. So this should pop up as a final file, and this too. So now we're going to create a task, and very soon we see it in the processed archivals task. Here we get an option to process all the sites. They all look fine to me. So no, actually, this needs rotation. So I'm going to rotate it. And one more thing, we actually have a very smart way to see if the crop was good or bad. So what we do is, whenever you hover over any image, you'll see an eye icon. When you click on that eye icon, you see 3 aspects of the image. So the first is the crop itself. The second is the boundaries, which shows you the boundaries on the proper image, what area did we crop. And third is the remains. That shows you what was left behind in the image when the crop was done. So as we can see, this gives the user immense confidence that they have done the correct thing, as nothing is remaining. The boundaries looks fine to me. And the crop is, we are not missing anything on the crop. And after that, I'm going to click create archival. This would be archival with the P number 55. So here is 55. I'm going to click on 55, and we can have a final image of the archival. So that was my part. There are a few more things which I want to talk about. I'll tell that. So the first problem was the architecture itself. So the current scenario, it works on 2 parts. The presentation layer, which works on PHP, that's our framework, and the logical layer, which works with Python and OpenCV, that actually processes the image. And we connect them using a task queue. And about the object-oriented aspect of the nature, we have an archival class which takes 6 image class objects. The image class objects contains nothing but crops of the images, and the archival class creates a map which stitches them and makes the final archival. My future goals is to extend this current implementation in a more robust manner, and also create an on-device or an edge image processing service. My name is Aman Singh, and I'm really thankful to all the members who helped me to get through this Gsoc, all the people who helped me build the solution. And Jacob, of course, he helped me immensely, and I think he helped every person on the Gsoc team. Yeah.
Great, thank you very much. That was really cool. I loved seeing the demo of it. Very impressive how it's automatically cropping, and it'll be very useful for uploading. Do we have any sort of immediate responses from people on the call, or do we want to move on to the next talk? Okay, no immediate clarifications or questions, so let's move on to Nishil. Are you
Yes.
ready? Do you want to share your screen?
Yep. Do let me know when you are able to see that.
I'm able to see it. Yep. Go ahead.
Yeah. So hello everyone, I'm Nishil John, and I participated in Google Summer of Code 2020 with Cdli. My project was General Management and Display, and it was mentored by David Wong. So I'm from Karna Institute of Technology and Sciences, Coimbatore, and I'm basically from Chhattisgarh. So my overall project was to create a journal dashboard so that we can ease the process of overall articles upload, which Cdli hosts, and then convert the articles into the desired format, which has been uploaded by the editors, and same as manage all the mathematical equations, bibliography, and other details of the latex. And miscellaneous part of this project was to migrate all the previous year articles and display them, as well as improve the development workflow by initializing CI/CD, unit tests, and lint tests. So these are the 4 types of articles with Cdli hosts: CDLJ, B, N, and P. And on the right side, you can see the desired formats which is needed for the publishing of the articles. And on general, the editors will make their articles in the LaTeX format, and the dashboard will handle it to convert them into the desired format. So for CDLJ, it's PDF and HTML. Same for CDLB, and for CDLN, it's only HTML, and for CDLP, it's PDF only. So the overall article upload process I have divided into three parts. The first is the insert of articles. That means based on journal details like title, year, author, and their publishing status. The second part of the article upload is to convert them into the HTML from the latex upload of the editor. The third part will be to display the article of categories and their individual articles themselves. So this is the overall article publishment demo. So first the editor can select the type of articles which you want to upload. Once it's completed, the editor can actually upload the journal details of the article, like article name, the serial number, and the author. So we do have an auto suggest author where they can get the author name by auto suggest, and if the author name is not present, so we'll create a new identity for the author. On the second part of article upload, we'll convert the LaTeX file into the HTML and desired format. So on the left part, you'll see the LaTeX code of article template, and on the right side, you can see the generated HTML code. So how it is processed is based on we register all the LaTeX tags, and we have made a code base of all the tags which is present in LaTeX. Then we appropriately map them into the HTML format and we display them. So here's a sample for the article upload conversion process. So the editor can upload the LaTeX file. Then he gets an anchor tag for managing the HTML content, where he get the overall HTML content of the LaTeX file. He can also go ahead and edit the LaTeX file and also see the conversion log that what has been done. Then the management of image and bibliography was a really critical task. So once the article is converted into HTML, we give them a different section of image manager and bibliography manager where they can go ahead and upload the images and save them. The converter reruns and populates all the images which are present and the editor wants to map. Similarly with the bibliography file, we first list down all the bibliography tags that we has identified in the LaTeX template and simultaneously map them into the data which we got from the bibliography file. So you can see that after a second run from bibliography manager, all the bib data is now populated. So the editor can actually refresh the converter if they have not got the desired result and can see the logs and also the LaTeX file. Other than the display of the articles. So when they have reviewed their HTML format, they can go ahead, upload the article PDF, and then see the overall preview of the articles. So once they are satisfied, they can upload the PDF and then save the articles for the display. Yes. So they have made on create status and they have saved the article. So now the article will be open for user as well as admin to view it. On the admin panel, you can have the actions of edit and PDF view, and this will be the HTML view on both the ends. The challenges of my project was the conversion of articles because there were a lot of LaTeX tags that we need to capture and map them to the HTML that was done using the LaTeX. Managing images and bibliography was also related to mapping. So the overall idea was depending upon how good we scrape and extract all the data from the LaTeX tag, then we go for a mapping. Migration of previous year data was difficult because we were using a Drupal module and no data of previous year was mapped well for our relational database. The last part was the UX and documentation. So the overall project goal was to make it for editors. So we wanted to make sure that the editor can use them based on their knowledge, and we wanted it to make as easy as possible. So this is my overall project timeline. So I started the community bonding on May. Then on the first milestone, I made all my converters, models, and CRUD operation from the articles. On the second milestone, I started a display of my journals based on dummy data. In the milestone 3, I started the conversion based on CRUD operations and extracted all the latex tags and provided them into HTML. In the near to my final submission, I started migrating the schema and raising the pending tasks which were not able to complete during the Gsoc. The miscellaneous part of the project was to help the overall development workflow, which is happening in Cdli, by giving them a CI/CD, continuous integration and delivery, where they can run the general test, including lint and unit, in their pull request itself. The pending task in the framework right now related to test is to provide a good code coverage using code climate. So my overall Gsoc experience was really good, and this was my second attempt to Gsoc. The experience which I got from the community was amazing, and I got to learn few teamwork skills and discovered new technologies which my fellow mates were using. And I was always able to cover all my schedules and pull requests, raising them in due deadline. So it was a really good experience to overcome all my challenges and meet the deadline. So what's next? So my future plan with CDLI and overall open source is to finish up a few pending features and improvements on the overall dashboard, improve the journal dashboard and the converter itself. So I worked a lot with Jacob on improving the converter, and I've got a really good feedback. Now my task are to implement them on a global basis, then provide tutorials and documentation for editors. And my next plan in terms of CDLI is to mentor the new contributors coming up to Gsoc and open source itself, then improving CI/CD and the overall development workflow and keep contributing. So thank you. So you can download my presentation on the link, and this is my contact. Thank you so much.
Thank you, Nishio. That's really excellent, and I think that'll help facilitate the publications that have in the past come out of the CDLI and hopefully in the future. And I heard a little bird told me that we'll soon get some news about new publications coming out of the CDLI in the very near future. So your tool will be greatly appreciated. Okay, so next we have Ajit, who's going to talk to us about managing bibliographies. He submitted a video, so you'll have to give me just 1 second to switch over the stream. So we've got video up here. Okay, there we go. And okay.
Hello everyone. Today I'm going to talk about my project Bibliography Data Management System, which was a part of Gsoc.
I say yes, she says
My
yes.
mentors were Zoon and Sagar. Let's get started. So CDLI has developed a new fully relational database from its old flat structure. So to handle the bibliography data in this new database, the aim of my project was to be able to create features for the admin to manage the data as well as for the users to search the required data from this. These are the objectives which I completed. Let's go through them one by one. First is managing and viewing publication data. This included admin features like publication index, add and edit pages, and public features like publication index for the general public and view publication. Let's have a look. So first, for the admin publication index, we have all the search criteria here through which we can search. So if we give entry type as book and we can narrow it down to search by 2010 year, and we hit search. So we have the results from there, as we can see, and we have edit and delete options over here. And then next we have add new publication page. So these are all the columns in the publications data table that we can fill. And additionally we have author list and editor list. So author list, we type in characters, and on entering 3 characters, based on that it will give us suggestions, so we can select from that. So if we select this author 1, then we can select one more. Similarly, editor we can add. And now if we try to submit, it shows an error because none of the fields are filled. So we at least require a title to be able to save. So we can enter a title here and then we submit and it gets saved successfully. And similarly, so edit feature also has the same structure, and then finally we have view page. So this is the view page containing all the data and we show related artifacts. So this one has no related artifacts to it. So the publication index also has a similar structure, only that the sensitive information is hidden from the public and not shown to them. So that's the only difference, and that's it for publication. Next we have managing and viewing authors data. So similar to the publication data, we have the same structure of index, add, edit pages for admin, and author and index and view pages for the public. So let's have a look. So this is the admin authors index, which contains all the entries in the alphabetical order, and we have a alphabetical pagination as well. So if I click on L, it goes to the page where the author with name L with the first letter L starts. So this is the pagination implemented for this, and this is the add pages for that for the authors. So these are all the details, and the first name and the last name, one of them needs to be present. So if we directly submit, it won't accept that. Also the name needs to be unique, and we have an e-station order for storing the names in that format. So if we select, the name will be saved in e-station order. So based on first name, last name, and this field, we generate a full author name and save it in the database, which is used for the display purposes on all the places. And then finally we have authors view. So if we click on any other author, we have all the details and the related publications to the author as well. So that's it for the author side. Next we have associating publications to artifacts, that is linking of artifacts to the publications. This is an admin only feature, and there are 3 ways for associating the data. We'll go through them one by one. So first we have direct association. So we can give any artifact ID as well as any publication BibTeX key. So this provides us an autocomplete feature based on our input. So if I type in, we'll get suggestions and we can select one of them from the existing values, and we can fill in comments, exact reference, and the publication type, and we can submit to save. Then another way is through the publication view page. So for a particular publication, we have related artifact section, and here we have link artifacts. So we can link artifacts to this particular publication. So we can go here, and yeah, here we have a brief idea of the values for the publication, and here we have linked artifacts to this particular publication, a list of them, to make it easier for the admin to change the data. And then here accordingly artifact ID can be added and other data can be added and submitted. And similarly, this is accessible through the artifact view page, and we have artifact information as well as a linked publication to the selected artifact, and the data we can input here with publication BibTeX key as the identifier for the publication. So these are the 3 ways. And next we have bulk data upload. This is an admin only feature. So for this feature, a bulk upload component was implemented to which is able to handle any of the tables we have. So for the purpose of my project, the bulk upload was implemented for the following tables: publication, artifact publication association, author publication association, and editor publication association. So let's look at one of the examples for the publications data, bulk upload publications. So we'll choose a CSV file which is in the required format, and then we'll submit. So this after submitting, we have a validation error report. So if there are any sort of validation errors, it will show up here, and if there aren't, it will just proceed to directly save. So because we have the errors, we have this report here right now. So we have line number in the CSV file, and then this is the data. So all the data columns like BibTeX key, authors, year, and the corresponding data is shown. And then at the end we have errors, what the error is and why this validation error occurred. So it shows up here. We can decide to proceed, and if we proceed, it will just go on to save the data which doesn't have any errors, and it will give us a final error report, again in a similar format, line number, data, and the errors. The difference between this and the validation report, error report before this, is basically it on top of the validation errors, it also shows the other forms of error, like if any entry which you are trying to save is a duplicate entry, and many such errors. So at the end, we have an option to export all the errors as a CSV file. If we do this, we get a CSV file download, and once we open that, we can see that this contains the uh, entries which had errors. So we can just like look at the errors here and fix it in this CSV file, and then re-upload the CSV file to complete the saving process. So that's it for the bulk upload data. Merge publications feature. This is also an admin only feature. So the convergence from old database structure to the new database structure is not perfect, and it leads to many duplicates or near duplicates for the publications data. This feature aims to help the admin to help in this process of cleaning the data. Let's have a look. So similar to the publication index, we have the search based on the fields. So we can search based on any of the fields provided, and the search results are limited to 50 results, and we have all these results here. So we can select the entries which we think are duplicates, and we select merge. So here we have the 3 selected entries data, then we have all the details. So the details are filled based on the first publication. So the merge works in such a way that it like the first publication details are given which we can modify, and the remaining ones are deleted, and all the related artifacts. So here we can see all the related artifacts to all the selected publications are displayed here. We can edit their relation data, and we can submit for merging. So here we can have a look at the first publication. So this is where it will get merged. So it has only 3 related artifacts. We finalize the details and we click on submit. So all publications have been merged successfully. So now if we look at this again and we refresh, we have all the related artifacts, and again if any fields would have been changed, it would have displayed here. So this is the merge publication feature. Those were all the features. To conclude, this project will help the users to find the required bibliographic data, as well as it will help the admin to manage and improve the quality as well as the quantity of the available data. So possible future developments include extending bulk upload to manage other tables like artifacts, as well as some features which can be developed for associating other related data for artifacts as well as for the publications. So that's it for the presentation, and thanks everyone for being present. We'll conclude here.
Okay, thank you, Ajit, for your video. That was very interesting. It'll really help to manage all the immense amounts of bibliographical material on the Cdli. It's very important to have all this stuff and have it sort of well structured within the database. Before we move on to the next presenter, we just got word to congratulate one of our mentors, Rune Rottenberg. His daughter was just born, so congratulations, Rune. Sorry you can't be with us, but you're doing something slightly more important. So now we're going to switch over to Samarth. Samarth, are you there? Can you share your screen?
Yeah, sure. Hey everyone, my name is Samar, and for this Google Summer of Code, my project was design integration. Before I get started, I would like to thank my mentors Aman Biswas and Aman Iqbal for supporting me throughout the Summer of Code program. Also, I would like to thank Vedant, Nishil, Lars, Emily, and virtually everyone for solving my doubts, reviewing my PRs, and giving me more insights about how I should design or incorporate more features. So thank you for that. Now, the basic overview of the project is that my Summer of Code project had two deliverables. One of them was the UI integration, and the other was accessibility enhancement. Now, both of them go hand in hand. The basic aspect was that the neat and pleasant UI should also be paired with an accessibility. Why? Well, simply because a website accessible to everyone will not only mean we open the door to a wide range of users, but will also go towards helping make the web accessible for virtually everyone. To talk about the problem statements, I've categorized them in two broad categories, where UI integration is subdivided into even more categories. So starting with the UI integration, the old design was partially integrated to the new framework. Now the challenge was to take over the remaining layout, and by writing the remaining style sheets and filling in the cake PHP templates for the remaining elements, I had to cope up with a lot of code mixtures and overall writing skills of multiple users and developers out there. That was a bit challenging, understanding each and everyone's code and moving on with it. Apart from that, the Node.js support was something that I struggled with a lot. Now, uh, for right now, a lot of features in the UI depended upon JS functionality. For example, the drawer, hiding and showing select few elements. These were all made up using JavaScript, or otherwise they were paired with Bootstrap to incorporate the layout. Now, Bootstrap also relies on JS, so that was a bit of a problem. So we had to rebuild a lot of helpers just by using HTML and CSS only. Also, I would like to thank Lars for helping me in this, along with Vedant for providing additional support in the Node.js section. Now, when it comes to the UX enhancement, the primary task for any UX enhancement is to make things a little more linear and much more helpful for the user directly. The basic uh, thing about any UX is that a meaningful user experience allows us to define better features and practices on a website or an app that's the most conductive to users' ease. That was one of the important things that I also had to make sure. And last but definitely not the least was accessibility enhancement. Now, CDLI project has been spending a lot of energy on developing its framework to share its data and tools to the public. But the one thing of concern was the overall accessibility of information that we share. In other words, the main task was to make sure we can cater differently able users as well, be it in terms of vision, steadiness of hand, cognition, or more. So right now I'm going to share you some of the screenshots of the layouts that I have built following the beautiful UI prototypes that are designed by Aman Viswas. So as you can see, these are some of the newer layouts. The artifact and browse page are on the left side of the screen, and on the right side we have the search results. Now, for artifacts and browse, the page layouts are very much linear, and information is present right in front of the user without any complexification of data at all. And as far as the search results go, the search results are now optimized into a dual view. One of the view is a card layout view, and the other one is a table version of it. Now, why two views? For example, when people are quickly looking over for instant information, the view of just having a one particular layout was quite challenging. So adding all of that in a horizontally scrollable table was something that was very much beneficial when you're looking at multiple information at one go, as compared to the card layout. Card layout is also something similar, but it's for a different purpose when you're looking for something much more visual. So that's what the outcome of designing a dual layout for the search results page was. Another one of the challenge was the advanced search page. The advanced search page is something that lacked a huge cluster of the UI portion. All of the text fields, input fields, and the information were arranged in a hierarchical manner, which caused a very complex user experience, and most of the search boxes and fields were quite misplaced. They were not placed in some sort of a category header so that the user can easily jump to a textual data category or a publication data text field. Now, these are some of the more screenshots that I've worked on. Apart from this, here is a sample of quick links. I'll quickly open up the prototypes that were shared by Aman Biswas that I've religiously followed throughout the UI integration of this website. So here's the UI side of things. As far as the integration of these designs goes on the CDLI framework, these are followed 100%. They look exactly the same as they are presented here right now. I'll drop in a quick link in my slide as well, so that you guys, if you're interested on working or enhancing the layout, you can actually work on it. Now, apart from it, I plan on to work on accessibility more. Right now, all the pages have an accessibility criteria of WCAG 2.0 criteria A, and some of the pages even have criteria of AA, but I plan on to work on to make sure that every single page on the CDLI framework has an accessibility criteria of 2.0. And for works past the Gsoc, I plan on to work on even more layout pages. Some of the layout things that my fellow members during the Google Summer of Code built, I plan on to add even more UX and UI advancements over to that, and possibly even more accessibility enhancements over there. So that's about it, and thank you.
Okay, thank you, Samarth. That's really excellent. It's going to make such a huge difference for the CDLI. Um, so yeah, okay, we're on that one. So next up, we have Vedant, who worked on the CDLI search and access. So you should be noticing a theme here. A lot of these talks have to do with fundamental kind of changes to our framework and website, and hopefully we'll have a little bit more information to share at the end about when you can be seeing this. Okay, one sec. We have a video to switch over to.
My project for Google Summer of Code was improving CDLI framework.
There we go. And I'm sorry about the audio for videos. I'm trying to make it louder, but there's not much I can do. So here is the
Hello everyone,
Vedant's video.
I am Vedant Pakilkar. My project for Google Summer of Code was improving CDLI framework. For this project, we were a team of two. I was a mentee and Emily was my mentor. Before I begin, let me give a brief overview of the CDLI framework. The CDLI framework is a newly restructured, redesigned website to increase usability and accessibility to the data it manages. It includes a unified interface for the project website, powerful search, links to navigate the artifacts, and many more. The main aim of this project was to improve CDLI framework. The objective was building an authentication and authorization system for the framework, integrating Elasticsearch for simple search, optimizing queries for advanced search, preparing search results, expanded and compact format with data pre-processing. The first objective is to extend the authorization authentication system, which consists of 6 sub-goals. We will address each sub-goal in upcoming slides. Bypassing two-factor authentication. The issue was users were able to bypass two-factor authentication, which poses a major security concern. After implementation, the outcomes were authentication was made more secure and no user can bypass two-factor authentication. Let's see the demo. New user try to register. User fill all the required credentials. On submitting, he will be redirected to set up two-factor authentication. If user tries to skip two-factor authentication, registration fails. User has to register again. set up two-factor authentication. An account is created successfully. Now user will enter login credentials. On submitting, he will be redirected to verify two-factor authentication. If user try to bypass two-factor authentication, then login fails. Next is setting up a role-based access system. There was no role-based access present in the framework. In role-based access system, user is assigned different roles according to which respective functionality can be accessed. Finally, the framework supports role-based access system. Strong password checker. The main aim is to force the user to create a strong password. The password entered is checked against most commonly used passwords. Implement password retrieval. Forgot password functionality implemented along with additional two-factor authentication security layer. Fix logout. The user was able to log out using GET request, which was a security issue. This was fixed by accepting only post request. Let's see the demo. User tries to log out using GET request, that is appending /logout to URL. In this case, the user is again prompted to log out using logout form. Making account inactive. In the current framework, if the user is inactive for more than 6 months, his account gets deactivated. It can be reactivated by requesting admin. Next main objective was simple search. Before getting into simple search, let me tell you about Elasticsearch. Elasticsearch is a distributed open source search and analytic engine for all types of data including textual, numerical, geospatial, structured and unstructured. Adding Elasticsearch to our search module will make search more efficient and with less response time. Cdli database is a SQL database which supports object relation mapping, and Elasticsearch requires object document mapping, which is supported for NoSQL. So, to index data into Elasticsearch from SQL database, we have to use logstash. What logstash does is it uses JDBC client to fetch data from SQL and index it into Elasticsearch. It performs operation periodically so that updated data can be indexed in Elasticsearch too. This was the overview of how Elasticsearch was set up. To search index data in Elasticsearch, we have to use Elasticsearch API to query and obtain results. This is the overall setup of Elasticsearch for simple search. Outcomes after implementation. Now, simple search is an Elasticsearch based search. It is 10 times faster than previous simple search. Let's see the demo for simple search. Let's try to search keyword India for search category collection. We can see there are 4 results and took less than a second. Let's try to use regular expression in dash star and search again. We will change the page size to 100. So for regular expression, it shows 89 results and it almost took a second. Next is advanced search. At the start, we decided to optimize the current advanced search, but after integrating Elasticsearch with simple search, we plan to extend Elasticsearch support for advanced search too. Hence, advanced search was built from scratch. The outcomes are expanded Elasticsearch support for advanced search, added filter support for advanced search. Now, user can use various filters to filter out results as per the requirement. caching set of results to fetch next set of results easily, able to retrieve 0.3 million results within a minute. Let's see the demo for advanced search. We will search collection, India star and material limestone. These are the search results. Let's modify the current advanced search. We will update the material to clay and search again. Let's update result per page to 100. So here are all results. Now let's modify advanced search again and add author Widel. So now we see all the results where the collection is India star and material is clay and author is Widel. The fourth objective is search functionality. It includes search setting page, filter for search results, and lastly, expanded and compact view search results. Search settings. There is a separate search setting page where user can set results per page, filter categories to be displayed on search result page for different views. Let's see how the search setting page works. This is the search result page. We will open the search setting page in new tab. In the expanded full view option, we will uncheck museum collections, materials, and artifact type filter category. On search result page, this is the filter part. We can see 5 filter categories under object. Let's save the updated search settings and refresh the search result page. Now we are left with only 2 filter categories. Let's try adding language filter category. We will save the search setting and refresh the search result page. We can see the new filter category language added under textual data. Filters. The main aim was to develop functionality for the interface that allow users to filter search results quickly based on the filter values. In short, to filter search results according to user requirements. Let's see a short demo of how filter works. This is the search result page. Now I want to apply filter where provenance is Dagan, material is clay. I will apply selected filters. This is the search result after applying filters. Now let's filter based on author open and apply filter. So finally we have only one result where provenance is Dagan, material is clay and author is Owen. Expanded and compact view. Search result page support two types of view, expanded and compact. The main aim was to pre-process data and display based on the type of the view. Let's see small video for expanded and compact view. This is the search result page by default set to expanded view. Let's switch to compact view. This is the search result page set to compact view. Rocket Chat integration. So what is Rocket Chat? Rocket Chat is a free open source solution for team communications. We will set up Rocket Chat on Cdli servers and ship from the current team communication platform to Rocket Chat. Post Gsoc, I will be adding filter support for simple search and documenting all the remaining models, and I will continue contributing to Cdli. First of all, I would like to thank Emily for helping and guiding me throughout the Gsoc journey. I would also like to thank other co-mentees and mentors for collaboration. And lastly, to Google Summer of Code for providing an opportunity to work with Cdli. You can find all the demo videos in the final report on this link. Thank you.
Okay, thank you, Vedant, for the video. As someone who uses the Cdli search all the time, these are much needed and huge improvements on the current interface. So I'm really excited. And I think many Assyriologists and people with general interest are very excited to see these types of developments roll out in the near future. So that finishes our first block of presentations. We now have some time for questions. If there are any questions from either people who are on the Google Meet right now or folks in the YouTube live stream. Remember that there's a little bit of a delay, so it's best to get your questions in early so that we can see them and respond as quickly as possible. So I'll open the floor to questions. Yeah, we could take a short break, or I was also thinking, Emily, do you want to say anything about the rollout of the new website, the new framework?
So we're currently looking at when we're going to be able to deploy the framework for public viewing. We're going to set it up at Compute Canada, but I'm not sure exactly. We don't have a set date, but it's going to be during this month, the month of October. Sorry. So as soon as we have news on a specific date, we'll spread it to everybody, so we can have some people testing our work as soon as possible. And whatever feedback we get, we will be able to integrate it into the platform as soon as possible for when we finally deploy the framework in production.
Yeah, so that'll be really exciting. So people will be able to try it out and give feedback along the way. If you have a particular way that you like to search the Cdli and see how things pop up, you can kind of give that feedback, and hopefully we can find some way to accommodate your particular user experience with the Cdli. Okay, I'll watch for questions, but until then, I'll just put up a schedule so that you can see when the next talk begins. And so in lieu of any questions, we'll be starting at 12:05 with Rachit talking about machine translation models, and we have a video from him that we can show. Okay, we're going to get started again. So we're now, as you can see on the schedule, we're about to start the kind of like machine learning, machine translation pair of projects and talks. Both are videos, so we'll be sharing the videos of the two students. So we'll start with Rachit, and then we'll move on to Himanshu's. Rachit's presentation is a little long for the block that we have, which is okay, but so we'll have to cut it off so you'll get a taste of what he worked on. And if you want to know more, we'll make sure to upload the full video online. So let's switch over and get started.
Hi everyone. Today I'll be presenting my work on neural machine translation for Sumerian English, which I carried out with Cdli during this summer. My mentors during the program were Dr. Nico Schenk, Ravneet Punia, and Dr. Jacob Dahl. So a main objective in the project was to translate the entire Sumerian UR3 corpora with Cdli by specifically making use of the monolingual text across semi-supervised and unsupervised techniques for machine translation. So the primary motivation behind doing so was that we have about 1.5 million monolingual sentences, while only around 8,000 parallel sentences, human translated sentences in the CDLIS corpus. And the previous models which have been developed for machine translation do not make use of this 1.5 million sentences, and even the parallel sentences that have been used are trained on the raw parallel text, and they are quite sparse and irregular, due to which the models lack contextual understanding of the languages. So these are some partial phrases which are present in the raw parallel data. So you can see that there are about 2 to 5 words in both Sumerian and English in such cases, and if such partial phrases, as I would call it in my entire presentation, partial phrases or segments are used for machine translation, then the models are not expected to have contextual understanding or any references. So we reframe such sentences by concatenating the partial phrases to have complete sentences, which we can further train our models on. So firstly, we do this to have stronger baselines by doing a supervised learning approach on such complete sentences. We test across the various data configurations, and one such was the UR3 configuration, where we only use the in-domain UR3 corpora to train the model while using the complete sentences. So a complete Sumerian text goes into the N encoder blocks, which passes the encoding to the decoder, which gives one by one word by word outputs, which goes into the decoder again, and in this manner iteratively we finally get the complete sentence. I won't be focusing much on the technical aspects or the model explanations, but more on how we solve the problems specifically to our domain, that is Sumerian English translation. So this was one of the data configurations which we used. Another one was similar to what that has been used in the past, is the UR3 UR3 seg, which contains partial phrases and segments from the UR3 corpora. Again, only UR3 corpora, that is the in-domain data. So such partial phrases go into the model. So I show only one example here, but obviously there are around thousands of sentences which are used to train. So this is the UR3 seg, and then we have the all seg configuration where we use even the out of domain data from all genres of Sumerian text, but still the partial phrases. And then the finally, the all-com configuration, where we have the complete sentences across all genres of Sumerian text. So not only does this provide out-of-domain knowledge and out-of-domain language understanding to the models, but also complete sentences. And we found out that this type of data configurations gives us the best baseline, and we further use this to compare our semi-supervised and unsupervised approaches. Now, these approaches, we basically broadly divide them into three categories of self-supervision plus fine-tuning, data augmentation, and back translation. So now we'll see them one by one. Firstly, the self-supervision and fine-tuning. So self-supervision is a term that is used for machine learning tasks which are done with or without references, but mostly what we do here is that we have some perturbations in the original text, in the original source of our data, that is the input, and we aim to have some output which could be derived from the input itself. Like, for example, we used the masked language modeling, that is MLM, and translation language modeling, that is the TLM tasks here. So in the masked language modeling, we mask one of the tokens from our input sentence, and the aim in this, the task here, is to predict this masked word. So as you can see, we only have an encoder here. So in the self-supervision phase, the self-supervision is used for the pre-training of the model. So we use the encoder to pre-train our model, to pre-train the encoder basically by using such self-supervision techniques. So tasks, I mean. So this masked token is to be predicted, and we pass the sentence as we were doing before, but now the encoding directly goes to a feed-forward layer and a softmax layer, and the output is obtained here. Like, the masked word originally should have been this, and that's what we need to predict. So performing this and the translation language modeling, where we do not only have one language in the input, but we have Sumerian as well as English both present together. So we have a partial phrase, or one part of the sentence is taken from Sumerian, while the another part is taken from English. So we do this, and we pre-train again using the self-supervision task of TLM, and now the Sumerian and English tokens have been masked again, and the objective is same. So we see that using TLM gives a huge rise in the performance also. So in the pre-training phase, we perform these MLM and TLM tasks to have a pre-trained encoder, which we further fine-tune using our original model, that is the stacked encoders and the stacked decoder model. So specifically here we experimented across XLM and mass, which is another configuration of transformer. So for fine-tuning, we again have two approaches, either of which could be used. So in the denoising autoencoding, our approach is similar to what we just saw in masked language modeling, where some perturbation is applied across the input sentence, and our task is to predict that output the same input sentence again. So this is done for fine-tuning, and as you can see that no parallel sentence, English sentence is required for such a task. Thus it is an unsupervised technique, the denoising autoencoding, while the another approach is machine translation, which we all know uses a reference target sentence in English to train the entire model. So that would be a semi-supervised approach, because we first used monolingual data to pre-train the models, and now we are fine-tuning it using the parallel sentences. Thus we have either of these could be used, and we experimented across both of them. Yes, so further, one major problem that we faced during these processes was the problem which we would like to call the catastrophic scarcity problem in Sumerian and English. So this problem is that the target level sentences that we have for in our parallel data, which have been human translated from Sumerian, are basically translated on a small words of partial phrases or very small phrases level, and thus
Okay, if you want to hear more, you'll have to check out the video when it's uploaded to YouTube. But unfortunately, we do have to move forward with our schedule so that we can keep on time. So sorry, Archie, but we'll upload it and we'll make sure to post a link in the eventual YouTube version of this live stream. You'll see a link to the actual full video that you can check out to hear more about catastrophic scarcity and its implications for large-scale translation tasks. Okay, so next we're going to hear from Himanshu, also a video.
Hi everyone, my name is Himanshu, and this year I work with the Cdli organization on Sumerian Translation Pipeline project as my Google Summer of Code task along with my mentor Ravneet Punia. So basically, the primary objective of my project was to build an end-to-end translation pipeline which can take a raw Sumerian transliterated text as an input of UR3 period and can provide the English translation of those phrases along with the named entity recognition and part of speech checking. Most of the components of our pipeline can be generalized to any other low resource languages to obtain an interpretable execution of the techniques and to uncover linguistic phenomena in lower resource setting. In this project, I focused mainly on the sequence labeling task and the integration of the NLP pipeline containing POS, NER, and machine translation model. Machine translation project was handled separately by Rachit, which is already explained. So basically we worked with the 4 different datasets for our sequence labeling task. The MTAAC and ETCSL corpora were both manually annotated for morphology by Cuneiform Linguistics. Although ETCSL uses a slightly different tag set than MTAAC, we favored the MTAG tag set since it has also been mapped to universal dependencies. In order to reduce the data sparsity, we also performed text augmentation using the set of labeled named entities. One of the example is also shown in the third point. We got these named entities and it helped us to increase the number of phrases from around 5,000 to 20,000. On combining it with the ETCSL labeled data, it resulted to a final dataset for sequence labeling. The left image shows the composition of our final POS and NER dataset. The different tags were given along with the number of times they appeared in the final dataset. We used ATF file as an input for our pipeline. Cuneiform scripts transliterations are normally stored in the ATF formats, which are domain specific. We used these files and processed them further. We extracted the phrases, processed the text, and passed it to our pipeline for POS, NER, and machine translation model. We worked with these manually annotated dataset which were unexplored for such tasks and experimented across various algorithms ranging from simple machine learning models to advanced deep learning architecture. We basically used these 5 different models: the hidden Markov model, conditional random fields, bidirectional LSTM, FLAIR, and Roberta language model. Hidden Markov models and conditional random field are discriminative probabilistic classifiers which optimize the weights or parameters in order to maximize the conditional probability distribution. HMM is based on simple Markov process, whereas CRF is an extension of HMM which uses the set of features or domain specific rules that makes the model more robust for the specific language. We also developed domain specific rules for Sumerian, such as for example, if the word is followed by DUMU, which means son of, then it is most likely to be the named entity. Similarly, if the word starts with Lugal, which means king, is most likely to be the personal name, and if the word contains ki, then the word is most likely to be the geographical name and should be tagged with the gn. So we passed these set of rules to our crf model. Bidirectional LSTM is the well-known structure and is an extension of simple recurrent neural networks which deals with the sequential inputs. We tried it separately as well as with the additional CRF layer and with different word embeddings such as word2vec, glove and fast text. Flare is a language model which provides contextual string embeddings for sequence labeling tasks. We basically trained the bidirectional character language model using the Sumerian monolingual phrases and retrieved the contextual embedding for each word, which we then passed into our vanilla bidirectional LSTM CRF model. It can be observed from the figure. It basically uses the characters of words and generate embeddings based on its surrounding. So the same word can have different embeddings based on the surrounding words in a phrase. Roberta is the general purpose language model which is a modification of BERT. It proves to be performed very well for many natural language processing tasks and gave the state of art results. So we use the Roberta model and we trained it on 1.5 million Sumerian phrases along with the byte level byte pair encoding and fine-tuned it on our POS and NER corpus. It uses the transformer architecture and an attention mechanism which basically learns the contextual relationships between the words or subwords in the text. The table given below represents the metric score of our different models for POS and NER tasks. The conditional random field along with the domain specific rules gave us the best F1 score for the POS tagging task, even better than the complex Roberta and Flare language model, which are current state of art techniques for most of the high resource languages. The domain specific rules helped in learning the short term dependencies by learning feature weights. Roberta also performed very well for both of the tasks, giving state of art results for named entity recognition. The byte level byte pair encoding helped us to make the most out of the limited vocabulary and noisy text. We also tried Flare language model with various stacked embeddings along with the additional CRF layer for both of the tasks. Although the high precision is observed, but using this approach, but the F1 score is quite low due to the significantly low recall. In addition to F1 metric, we also conducted human evaluation by language experts for the best performing models. Out of randomly selected 76 phrases, around 500 tokens of words, only 8 and 6 words were misclassified by our NER and POS models respectively, giving the 1.2 and 1.6% error for the NER and POS tasks. We also did the interpretation of our Roberta model to analyze how basically model works. These are the visualization of our two randomly selected phrases from the for the sequence labeling task, indicating the attention given to each subword for tagging the target word with their predicted labels. It can be observed from the figure that the word kin and ku are the are contributing positively to tag KU3 BBAR as a noun, whereas in the right image the uh, UR, KI and HUL, which means destroy, is contributing positively to tag it with the geographical name. It can also be observed from the corresponding human annotation. The model interpreted similar to our human experts. It also depends on the tokenization. The different tokenization may result to different visualization and the uh, attribution on each subword or word. Our final pipeline basically has the following features. We can pass any ATF or the TXT file as an input. We also used the all previous human annotated data to generate our final kernel output results. Kernel format provides basically the extensibility and simplicity, which makes the conversion easy and annotation flexible. We have different choices for all the models in part of speech tagging, named entity recognition, and the machine translation. The final output generates with 4 files along with the one output kernel folder. This is a simple example which we ran on our pipeline. I randomly took one ATF file and passed it from the Cdli website and passed it to our translation pipeline, which goes through the part of speech tagging, named entity recognition, and machine translation. It can be seen from the right figure that our model performed well for all the tasks, giving the structural and informative output. The efficient use of previous human annotated data can also be observed from here. And with all these information, it is very easy even for a naive user to understand any cuneiform script, and this is what we were able to achieve. The pipeline can be easily accessed through the web API and can be then on any ATF file. Thank you all for listening and the Cdli team for providing me this opportunity. Thank you.
Okay, thank you, Himanshu, for the video. Really fascinating work for both Rakshit and Himanshu, and I think this shows obviously very sort of modern approaches to the language, but it really shows the power of the Cdli in terms of its ability to enable, basically, provide the data and enable all sorts of forms of future analysis that maybe we didn't anticipate early on in the project, but now are much easier to do with the wealth of data collected by the project. So we have time for questions. I see there was a question in chat, but it's already being answered. That's great. And I encourage anyone else who has a question to post it. And I'll give us a couple minutes to wait for questions, and then if not, we'll put the schedule back up. Okay, we have a question from Christian for I guess Himanshu, or maybe Rachit as well could answer. I believe it was examples of typical failures you might see in your pipeline. So what types of things would just break the model, right? What types of things would the model really have trouble with? Himanshu, do you want to answer that question?
Hi, am I audible?
Yes.
So actually there were little bit issues while translating the text in the machine translation model. There were some words which were repeated, but I guess it was because it was trained on the full text. I guess I think that it can explain it better. But for the pause and NER, there were issues with the verbs, which on training further, I mean, after optimizing, we were able to solve. But there were some words, I guess, which can be used differently in the phrases. I mean, one word can have a different tag. So the models were not uh, able to classify them at some places, and I guess that's what I observed. And I'm not very much. I, I don't have too much knowledge of the language, so I can't comment further on.
So you're saying there are some, you found that the model had trouble with words that could be in multiple parts of speech, for instance.
But yeah, but there were very few because after the human evaluation, we saw that only 8 to 10 words were misclassified. So there was a little bit issues in the machine translation, but some of the words were repeating, some of the words are repeating. So I guess in future we will be able to solve that as well.
Okay, thank you. Christian says earlier models had trouble with translating, what was that? Grain for metal. Yes. Easy to mistake for any computer. Right. Yeah. Okay, if there are no more questions, I'm just going to pop the schedule up, and we'll restart in about four minutes or so. Okay, we're back to start. So next up, we have 3 more talks, the last 3 talks of today's showcase. We have Anila talking about the mobile app for the Cdli, Lars talking about the API, and finally Logan talking about some really interesting stuff with accounting corpora. But to start with, we have Anilo, who spent all summer developing the Cdli mobile app, one of the many ways, but maybe one of the more important ways that the Cdli reaches out to, especially the general public, to sort of show how interesting and cool cuneiform is, if I do say so myself. So Anilo, do you want to share your screen with us?
Yeah, sure. I think you can see the slides, right?
Yep, you're all
Okay,
set.
great. Okay, so hello everyone. My name is Anila Hoja. I work on the revamped Cdli tablet apps project under the mentorship of Willis Monroe as part of the Google Summer of Code program. As you may know, Cdli provides daily highlights from its entire collection of artifacts through the Cdli tablet application. With this project, we aim to develop a new version of this existing application using Flutter, as well as provide a web interface for entering and managing data about the collection that will feed content to the mobile application. So work done in the project includes the improvement of the applications for both platforms, Android and iOS, the implementation of additional app features, and the development of the web interface for data management. Speaking technically, there are several reasons why we decided to use Flutter for building the mobile apps. So Flutter is an open source software development kit used to develop cross-platform applications from a single code base. It is flexible and expressive and allows animations at any complexity. All these features that Flutter offers made it easier for us to build a beautiful Cdli application with no compromises on the design process. So the revamped version of the application has an entirely new design and provides additional features like a search option, artifacts displayed in 2 different layouts and sorted alphabetically, and a help and feedback form where users can report any issues related to the application. I'll show you how the app works on my virtual device. Okay, so entries are displayed in a page view, like in the existing application, and information for each one of them is displayed in the sliding panel below. Users can share the entries on social media if they want to show a particular object to others. Then here's the search function. It works like this. And next, there's the sidebar for which we applied some animation. Actually, the background is dark gray, and it can't really distinguish dark gray from black color on the emulator, but it looks better on a real device. Again, like I mentioned before, entries are sorted by date in a grid layout and alphabetically in a list layout. Next, there's some information about the purpose of the app, and there's the help and feedback form, for which we integrated Flutter with Firebase to collect user feedback in Cloud Firestore. The logic behind the application is pretty simple. So basically, each view sends a request to the controller to fetch the data from the web API using the get HTTP method. And so this data is parsed from JSON and displayed back in the view. That was pretty much it for the application. Now I'll move on to the web interface. So the interface is developed inside the Cdli PHP framework. The administrator is able to perform CRUD operations on data, as well as search for a specific category of entries by entering the theme or by using a day-to-day search instead. This is how, so I'm logged in as an administrator. This is how the interface looks like. So the administrator can import new entries in the database by fulfilling all the text fields. And if I want the information for a specific category, I can search for it. And then there's a typo here, which I want to fix. So I'll edit the short description and save the changes. Okay. Next, the administrator can view the full collection. And for each one of them, there's a zoomable image property. That was a quick demo for the web interface. And as a result, we have a newly developed application fully working on both platforms and a new web interface for the data management inside the Cdli framework. That was pretty much it for my presentation. I want to thank my mentor Willis for his encouragement and guidance given to me, and Emily for her feedbacks and for always being very ready to help. I wish good luck to other students on their future projects, and thank you for listening.
Great, thank you, Anoa. That's looks great. And in terms of answering kind of the big question about when it will be available, we have to submit it through kind of like the moderation pipelines for both Google and Apple. So we'll make sure to send out lots of information. You know, if and when the new version, or not if, but when the new version becomes available on your favorite app installation store in a phone near you. Okay, let's move on to Lars. Do you want to share your screen?
Okay, hi. So I'm Lars Willighagen. My mentor is Ilya Kate. And this Google Summer of Code, I worked on creating an API for exporting Cdli data. So my main objectives were to create a number of APIs. So the general API, bibliography exports, inscription data export, and link data. And based on my findings, update the database schema. And I also had some additional objectives, and I will get back to that. But right now for the APIs, I first had to figure out general implementation details. So the user should be able to request an output format, of course, and that's either with a URL parameter or with an HTTP accept header. And those output formats should then be mapped to views, and in the views, the data should be converted to the output format. That makes sense, but for certain formats, the conversion requires external libraries. So the Cdli CONL files are present in the database, but to convert those to CONL-U, for example, there is an external Python library. So then the PHP backend has to talk to the Python library, basically. And then when all that's done, the view should also set the response header so the client can verify the request and the response. Now for the specific APIs, first off, the general API. This includes a JSON API for all catalog data. So this is basically the representation of the structure of the database. So you're able to export artifacts and publications and proveniences, everything in the database in approximately the same way that the database is structured. And then for artifacts and publications, additionally, there's the CSV API, which allows tabular exports. And this matches the file format used for the bulk publication, bulk upload, mentioned by Ajit earlier. So the URL schema looks like this. Basically, for any kind of data, you can request either a specific entity as JSON, for example, or you can paginate through the entire list, and we'll get back about the pagination later. Then for the bibliography, very similar URLs. The main exception is that for formatted bibliographies, you can specify a certain style. But basically, you can export BibTeX, you can export RIS and formatted bibliographies as well for artifacts, publications, and articles published by the Cdli. And this is implemented with an existing JavaScript library that I've been working on for a few years. So it takes in the input from the database, it converts it to CSL JSON, and then exports it to the various supported formats. So to add a new format, you only have to create a mapping from CSL JSON to the new format instead of having to map every single format to every other format. And for a publication that looks like this, so you have a formatted reference here, and then BibTeX and RIS. Yeah, for an artifact, there's a little bit less data because it's a bit more difficult to represent a website in bibliographical data, but that looks like this. Then for the inscription API, luckily the ATF and the Cdli kernel both are already present in the database. So I basically only have to send that as a response. So you can either request the annotation of a specific artifact, or you can list the entire inscriptions list as ATF, for example. And that looks like this, but that's pretty familiar, I presume. Then for the linked data, I mainly use the Cdoc CRM ontology. This was proposed in an earlier article by Cdli people about representing the metadata. And the linked data export is available in various formats, various common formats, and the URL schema is very similar to the earlier APIs as well. So I won't be able to show everything of the linked data, but this is a basic artifact. It's not very readable right now, and I can't get into everything. So if there's time at the end, I will. But right now, there's some identifiers here. There's physical dimensions here, and there are links to related entities such as publications and collections can be seen here. This piece is a structure for the archaeological information, so it has the provenience and find spot comments, things like that. And if you expand all the related items, so the publications and the collections, you get this, which is even less readable, but you can recognize, for example, the inscription over here and the publications over here again. But yeah. So to summarize the API, I think I went over all of this earlier, so I won't get into this specifically. Then for the additional objectives, the scripts API was an idea to use the external libraries for converting different files, for example, and provide a public API to use those via the website. I haven't gotten around to do that entirely, although I did make sure you can call the external libraries from the backend. So now you don't only have to make the backend so that it accepts requests for those libraries. Then for the HTML annotations, I added some meta tags to every page to make sure that when you send a link over social media, that images show up if they're there, and page titles are correct, that sort of stuff. Also, for example, for Twitter, that it knows which Twitter account owns the website. And then the other two I'll get into more. I hope I'm not running out of time. I don't think I am, actually. So
yeah, you're fine for time, so keep going.
Yeah. The API documentation basically describes what I've mentioned earlier in the presentation. So there's the different APIs, and then it lists all the URLs which support that specific API, including all the formats supported for that API. And then the output schema is also described. So that's pretty simple. I also worked on an API client, which currently supports exporting Cdli catalog data in various formats. And in the future, I also want to add support for logging into the website and support for search when the search API is done. So it's able to export the entire catalog because of the pagination, which I said I was going to get back to. So when you request a certain page, it's for example in JSON, it's you can't really send a button with, hey, here, click this button and you'll get to the next page. So what I did was add HTTP headers again for the different links. So you have a link for the first page and a link for the last page, etc. So it's the computer is able to extract those links and use that as a way to iterate over the various pages of artifacts, and similar for other types of entities. So, for example, in this case, I used the client to download link data for all time-related data, so periods, dynasties, and rulers. And that looks like this. So you can see the dynasties and the periods are pretty much done immediately, but the rulers take some extra time because for the link data of the rulers, the database also has to fetch related date entities. And then you can see the export file contains linked data of all those entities. And then similar for ATF. So this video shows that you can iterate over, paginate over the inscriptions and export ATF files from those into a single file. So I stopped the process early because I'm not going to fetch all the inscriptions, but that looks like this. Now I have more time left than I thought, so I will expand on the link data a bit. So for example, this is what I hovered over before, but that wasn't really readable. So this represents the artifact itself, and there are links going to the different identifiers. So we have the Cdli number and the designation and the museum number, for example. In the Cdoc CRM ontology, it's represented as an information carrier. And then, yeah, so the links are also with the CRM ontology. So you can also classify it with genres in the Cdli ontology, basically, and artifact types. So it's a lexical tablet. Then for physical information, it specifies it has a width of 52 millimeters. And you can specify the condition. In this case, it isn't specified, but the value would be here. And the material as well. So this is a clay artifact. And this is the archaeological information I highlighted before. So there are only 4 values, I think, represented here. So it has the find spot comment, the find spot identifier, the provenience, and one more thing, I think, but I can't find it right now. But there's a lot of other structure, basically, because the ontology that we use requires that structure. So the provenience is also as the ancient name, the modern name, and the coordinates represented. So overall, basically all the database, all the columns in the database are represented in the linked data. So I'm pretty happy with that. Then the inscription, basically the same. The inscription is listed. Sometimes there are dates referenced in the text, so those are listed as well. In this case, the data has no label, but language is also linked. So in this case, it's undetermined, which also isn't very helpful. But yeah, the challenge was in this case that the language, for example, in the database, it's linked to the artifact, while in the ontology, it should be linked to the inscription. So that made it a bit difficult to link those up. Then the Cdli conol also gets converted to conol RDF, and that's added to the inscription RDF. But I didn't add that in this case because the structure of the conol RDF makes it completely unreadable, because every word is linked only to the next word. So it's basically just a long row, and then all the text is too small to read. So that was it about the linked data, and we'll go back to the end slide. That was it for my presentation.
Are you still there, Lars? I think you're muted.
Yeah, sorry, did I get cut off at the
Yeah,
end?
you got cut out. Yeah.
Okay, yeah, no, this is the end of my presentation. Thanks
Okay.
everyone for help, and I'll answer the questions when we get to that part of the schedule.
Okay, great. Well, thank you very much. That was really cool, and it does a lot to help the Cdli sort of open up and integrate with other large-scale linked open data projects out there. So very important work. Okay, so last up we have a video from Logan Bourne. So let me just
Hello and
swap
welcome.
over to that. One sec. There we go.
Logan Bourne, and this presentation gives an overview of my work in the 2020 Google Summer of... Hello and welcome. My name is Logan Bourne, and this presentation gives an overview of my work in the 2020 Google Summer of Code, which I completed at the Cdli under the mentorship of Max Ionoff. The goal of this work was to extract information from Sumerian accounting tablets to make the content of these documents more approachable to non-experts and more amenable to quantitative research methods. This work was motivated by the fact that the Cdli data contains a vast amount of numeric information in the form of administrative accounts recording quantities of various goods. The numeric nature of this data makes it particularly amenable to statistical analysis and other kinds of quantitative research. It's natural to ask, for example, which commodities are recorded in the largest amounts, whether a commodity's distribution is unimodal or bimodal, and so on. But, at present, this analysis is challenging, because the data are recorded using Sumerian numerals. So, for example, if a document records a count of 250 sheep, this will actually be written as 4 gesh 1 u, meaning 4 times 60 plus 10. This notation is opaque to readers who are unfamiliar with Sumerian metrology. Even readers who are familiar with the notation may be slowed down by the need to perform this conversion, which is not always straightforward. It is certainly not feasible to perform any large-scale quantitative analysis without first converting the data to modern notation. For this reason, our project began by developing an automated conversion from Sumerian numerals to Arabic numerals. At its core, this conversion is simply a dictionary, which maps Sumerian signs to their modern values. However, there are a few peculiarities of the Sumerian notation which make this process difficult. The value of a sign may depend on context. So, for example, 1 dish means 1 in most cases, but when followed by gin, it means 1/60th. In longer strings, we may need to identify the boundary where we stop using one reading and start using the other. Sumerian also uses multiple different number systems, which have some signs in common with one another, but which use different bases and assign different values to the signs. For this reason, numeric notations can be ambiguous. Returning to the example of 1 dish gin, we claimed that this equals 1/60th, which is true in most cases, but when counting bricks, it actually means 12. Because of complications like this, when our conversion encounters an ambiguous number, it produces a list of possible readings, where each reading is labeled according to the number system which produces it. This ensures that users are aware of the potential ambiguity, and allows them to choose the correct disambiguation based on the context that the number came from. The conversion also supports subtraction, written using la in Sumerian, and small fractions, recorded with the circumfix gal. Now that we are able to process the numerals automatically, we're interested in knowing what is being counted in these texts. In some cases, this is straightforward. For example, in 1 gesh 5 dish udu, udu meaning sheep is the only non-numeric word in the line, so presumably that is the object being counted. But this logic doesn't work in a case like Tuban Dumunita, which naively looks as though it's recording 20 liters of male children. Obviously, this doesn't make sense, and in fact, this is counting an amount of barley allocated to the male children. The barley isn't mentioned explicitly in this line, however, and must be inferred from context. We also need to account for longer strings, such as this example, where we have an amount of pure large garlic. We want to identify garlic, shum, as the counted object, but we would also like to know that the garlic is pure and large, tsikil and galgal. To properly identify the counted objects, we use a rule-based system. Unfortunately, there is no supervised data available to train a more versatile machine learning model, and linguistic resources for Sumerian are limited, meaning we can't simply derive this information from, for example, a dependency parser. We use a variety of rules to identify counted objects, the simplest of these being word order. In Sumerian, the adjective usually follows the noun, meaning that the word directly after the numeral tends to be the counted object, and any descriptors will probably come later in the line. As simple as this rule is, it's sufficient for many cases. However, it falls apart in examples like the one on the slide. Here we have the word bahul immediately following a numeral. If we naively say that everything after a number is a counted object, we will make a mistake, since bahul in this context is a verb. This tells us that we should be taking part of speech information into account, which we accomplish by scraping the Electronic Pennsylvania Sumerian Dictionary. This lets us translate individual words into English and project part of speech tags from the English definitions. We can then limit our proposed commodities to words that are labeled as nouns. We also have a set of rules surrounding determinatives. Many Sumerian nouns are written with a determinative specifying the material they're made out of. This allows us to easily recognize items made of wood, metal, and reeds, as well as some categories of animal, such as fish. Such items are all commodities which are likely to be the counted object when they occur in a line. For words which are not written with a determinative, we use WordNet to find hypernyms of the word's English definition. We label some synsets as likely to be commodities, such as foods, clothing, and metals, and others as unlikely to be commodities, such as people and places. We use all of these features to construct a feature vector for each word in a sentence, and we use these feature vectors to jointly classify the words according to whether or not they are counted objects. At this point, we're able to automatically interpret the numbers and determine what objects they're counting. This opens a wide range of avenues for analysis. We developed a variety of visualizations intended to show off the possibilities, but these are by no means exhaustive. The visualizations are grouped into 5 components, which are included as part of the Cdli framework. These include a histogram, which shows an item's overall distribution, alongside summary statistics about the item. This gives an overview of the item's distribution and allows the user to identify features such as multimodality. We also have a similar items display, which lists the objects whose distributions are most similar to that of a given item. This can reveal sets of items which are used in similar ways, such as sheep and goats. The concordance view shows an item in context and allows the user to identify which uses are most common and in what contexts an item is counted in particularly large or small amounts. The nearby items view shows other items which are counted in tablets containing a certain object. This information can be displayed as a graph, where nodes represent counted objects and shorter edges represent more common co-occurrences. Cliques in this graph can be used to identify administrative subgenres, such as this clique of fish, beer, oil, flour, and dates, which derives from lists of goods delivered to festivals. Finally, the descriptors view shows words which are used to describe a counted object. Once again, we can construct a graph where edges represent common collocations. Doing so can reveal different use cases for an object, as in this example of words describing goats. Terms relevant to garment production occur separately from terms related to feeding, suggesting that the goats in these accounts can be divided into 2 main categories, those used for meat and those used for their wool. Although we've been able to extract and visualize interesting information about these accounts, there remain avenues for future work. We are limited by the quality of the definitions in the EPSD, which sometimes reflect obscure or uncommon meanings for a word. Better resources would improve the quality of the commodity identification. Furthermore, now that we have labeled some of the commodities in the data, this labeled data could be used to train a more robust machine learning model, to remove the need for the brittle rule-based system currently in place. To wrap up, this work has presented tools to convert Sumerian numerals to Arabic notation, to extract information about counted objects in Sumerian accounting tablets, and has produced a visualization interface to showcase potential uses for this information. Thank you for your attention, and a special thanks to the Cdli and to my mentor, Max Ionoff.
Okay, thank you, Logan, for that excellent and clear video explaining your project. So we've finished all the presentations, and now we have some time for questions, and I think there are a couple that queued up in the chat. Let's see, I think, Lars, there was at least one question for you about linking to external portals like Periodo, Pleiades, etc. Are we able to both contribute and or pull data from them yet? Oh wait, I'm muted on the Meet. Sorry. So we now have time for questions. So let's see. Lars, there's a question for you about linking to external data in the chat.
Yes. So there's a plan to add Pleiades mappings to the database. I haven't seen Periodo, so I don't know about that, but we could do something similar. And
Yeah.
as for British Museum linked data, as far as I know, all those resources about the British Museum linked data is gone. Basically, I've looked for it a while. I've asked on Twitter. There's a Twitter bot dedicated to checking if all that data is back, and it hasn't been since 2018. So I doubt that will work. But for the other two, that's definitely possible.
Yeah, I think I've heard of that kind of. I don't want to say scandal, but the kind of craziness of their data disappearing. Christian Kjarkas in the chat says that he has a local dump of the BM data, and it is indeed dead, which is too bad.
Okay.
It's a shame. Periodo is a really cool project. It aims to do kind of like crowdsourcing through linked open data of time periods. So it's a cool project that's been around for a while. So maybe that I was going to actually ask about that in terms of, you mentioned briefly that you were able to take dates from texts out and extract them for linked open data. Those are manually annotated, right?
Yeah, that's already in the database.
Okay.
Yeah, I think it's pretty full already. It's extracted from the old catalog, I believe.
Mm-hmm. Mm-hmm. Any other questions, either from the Google Meet or from the YouTube live chat? Logan, do you want to expand on the comment you posted about perhaps moving to better part of speech tagging?
Sure, I can address that briefly. So at the start of this project, of course, Himanshu was only just beginning work on his part of speech tagging work. So we didn't have access to a great part of speech tagger for Sumerian, and annotation projection was the best option available at the time. Now, of course, we have 99-ish% part of speech tagging accuracy from Himanshu's work. So I think a clear avenue for improvement in my own work is to integrate that.
Excellent. We have a question from Christian in the YouTube chat. In terms of written numerals, is there a routine in place yet to annotate the MTAC corpus? Maybe that's a question for Emily as well.
I don't think it's been integrated into the pipeline. So we've focused on part of speech and named entity tagging for now. But of course, one of the goals of the project was to identify numerals to help in the translation pipeline. So at some point, we will have to integrate it into our pipeline.
Right, because numerals can be important for disambiguation and things like that. Cool.
And to that end, there is a standalone API for identifying numerals in a string of text and for converting them. So it's just a matter of actually getting that integrated into the existing tools.
Yeah, I will say all the work on the APIs, especially by Lars and Logan, it's really going to help the Cdli sort of leverage all of this data in new and very interesting ways. So not just the user experience of finding things, but actually creating new forms of knowledge by making new pipelines and figuring out other ways to process the data into new forms of data. So really, really important work for the long term, especially. Any other questions or discussion points?
Christian is adding that he wants to help with integrating the numerals translation into the pipeline. So if possible, maybe both Logan and Himanshu could contact Christian to give him the required information so he's able to help with that.
Mm-hmm. Yeah, that'd be good.
Yeah, absolutely.
Okay, if there are no further questions, I think we can begin to wrap up. So first of all, I want to say a big thanks and job well done to all of the students who worked this summer. You all did amazing work. It was great to hear your progress every week in our weekly meetings, and to see the final products now is really, really nice. So excellent work to everyone, and thank you so much for helping out the Cdli. And stay in touch. You know, we're always looking for more contributions from people. You're more than welcome to stay with the project and keep working. There's a car beeping outside. Any students who are interested in contributing, or people with general programming knowledge or just general interest in the material in the Cdli, you're more than welcome to get in touch and join the project. There's always some small things to do, and so we really encourage participation from the wider community. Thanks also to the mentors for doing a good job mentoring your students and helping them along all summer. And thanks to everyone for tuning in today. So thank you, and see you later.
Thank you, Willis, for handling this this presentation today. And also thanks to the audience. We had a peak of, I think, 35 people watching. So and again, just to reiterate, thanks again to all the students and the mentors. I think we've done amazing work this summer.
Yeah, definitely. Okay, and this will be posted as a video on YouTube, and we will also upload the individual videos that we showed throughout the live stream so that you can watch them by themselves, and hopefully that'll deal with some of the audio issues that we were having earlier.